Yeah, so meanwhile, if people are coming, maybe let me introduce myself and also ask about your expectation from this course. So you're Akash, right? Okay.
Yes.
So, I mean, have you ever been exposed to coding or computational exercises before?
Yes, sir.
So
So,
what language are you comfortable with?
sir, C, C++, and a little bit above Python.
Okay. So this in this course you are right, the language which we are using is Mathematica, right?
Yes, sir.
So no experience of Mathematica before?
No, sir, but I really find like this is not too much unfamiliar for me because like almost syntax are as same as what we have used in C and C++, the same logics.
Right, exactly. So let me tell you, even I haven't used Mathematica before. So with this course, even I am gonna do things and just we are gonna, it would be interactive session. We are gonna basically use the syntax and do some physics problems. That's the idea. So who is the
Yes.
other person? Uh, Sharinida, can you hear me?
Yes, sir.
Yeah, so are you also familiar with some kind of programming exercises before?
Little bit of Python, sir.
Little bit of Python. Okay, okay. Python is anyways a very good language. I mean, I also use Python only, but this time let's do things with Mathematica. So the difference is that where there are many symbolic things which one can do with Mathematica, right? So expressions and all that, you can't just do them simply in Python. So it's like symbolic math. That is something which one can utilize in Mathematica. Okay, so if the let people will join, but we can start. So meanwhile, in between, you can stop me and ask, things if there is any issue. Okay, so this is the week one of this tutorial session of the course Physics to Computational Thinking by Professor Aditya Sharma. And I am a PMRF teaching assistant, and my name is Robin Bajaj from IISc Bangalore. So, right. Um, okay. So, have you gone through the week one lectures?
Yes, sir.
Yeah. So, what are the things which you learned basically from those? Basically, the simple things like visualization tools, what functions, how to create list, and all those stuff, right? Am I right? Can you hear me?
Yes, I can hear you, but
Yeah. Don't feel shy to discuss things. You can just talk. You know.
no, no, sir. I was just having a call. I actually missed the
Ah, it's it's
conversation.
it's it's okay, it's okay. So I was asking, like in your sessions, what you
Hmm.
basically learned in the first week of the sessions, like in the
Okay.
videos, what you basically learned. Can you just give me idea of so that I can go accordingly?
Yes, sir. So in the first session, like first of all, we were introduced to the Wolfram
Okay,
website, and
I
after
see.
that, inside of it, we learned how to basically. The most interesting thing I will say first is about the plotting things, because
That
those
is
things
true.
yeah, we
So
can
what kind of
visualize.
plots, did you do? Like simple continuous function or and also the discrete, right?
Yes, sir, both, and we also plotted the vector field. That was most interesting for me.
That is true. That is true. Okay, we'll try to do some sort of exercise related to that as well. Okay, that's it. So basically, you just learn mostly about plotting.
No, sir. The many basics were also there. It was kind of the same as what we have
Right.
learned in C++.
Yeah, that is true.
Okay.
Yeah.
How we use functions and how to like
Uh-huh.
analyze the function.
Okay, 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 fine. So, this you are familiar with this Wolfram Cloud, right? So I don't
Yes,
need
sir.
to go through this. Do you know like how can you look up to the documentation of this?
No, sir. I like.
Okay, so you click
Mhm.
this documentation tab. So let's say you don't know initially what to do. So you click this, you get a lot of tabs over here about what
Mhm.
can be done in this, right?
Yes,
So
sir.
let's first click this core language and structure. So this has all sort of functionalities that this uh, that Mathematica can offer you, right? So this is the first language overview that will basically gives you what all can be done with this. So see, I am also new to this, but how I learned it for the first sort of thing is I just went through these things. So it says how to create list and all and different functions of those lists, like what can be done with this list and the associations, how you can associate something to a value to something. That's how basically you create this. There are how to define functions and all those things. So what
Hmm.
I'm trying to say, this is something which can be learned only through enough practice, because if you don't do that, then these things will not go into your head in one go. So what do you have to do? If I would say, how would you have to start learning this? You get problem exercise every week, right? So
Yes.
before doing that, first you go through this documentation, just try basic stuff which they have, and they have examples also. For example, I click list. They basically tell you how to define a list. There is an example, okay? So if you see there, this is the example. If I just copy this, okay, and paste it over here, and what do I have to press to execute this? Do you know?
Sir, I think it was shift plus enter, like.
Exactly. So in MacBook, it's Shift plus Return. Okay. So this basically created a list. Okay. So that's the idea how lists can be created. That's what they told. That's the only thing. Now, in that also list, how to define the part of a list. Basically, different, like if I want to take a second element out, if I want to take a third element out, how you basically do that. So that's what it will explain. So let's just
Hmm.
try simple thing. I mean, so let's see. So you have this list. Let me define a list as list equal to A, B, C, comma D. Okay. Now shift plus return. So this is your list is defined. Now what I will do, list and the part which is second, and what it should give. What did
B.
it give? It gives B. So basically it gives the second element of that list. If I want to print last element, what can I do? Tell me. You have to tell.
So list of
That's how we will learn.
four, like under bracket and the address basically, which
Is
is
that the
four.
only way?
Uh, like.
That's one thing. Fine. It is
Hmm.
fine. Is there another way you can do? You
Yes,
can
sir. I
put
don't know the prompts
minus
exactly.
one. Minus one. Basically
Okay.
from the last. So you
Okay.
start the counting from the end of the list. So both of these are same thing. Okay. So this is how you will learn the syntax, just going through this. So in Python, if you remember, how would you print a particular portion of the list? Let's say it's a list with a length 4, right? You want to
Hmm.
print second to third element, that separate list. How would you do that? In Python, you would do that list or array, square bracket, 1 colon 2, because there the numbering start from 0,
Yes, sir.
right?
Hmm.
So that would be 1 colon 2. Here, if I want to print second and third element as a list, how would I do that? 2 colon 3. But I won't use colon here. It has to be this,
Double.
the two semicolons.
Okay,
So
semicolon.
yeah, so basically what I'm trying to say, you have to correlate it with the language you already have idea about, and then you can just go ahead. Okay, it printed 2 to 4. Okay, so I basically printed 2, 3, 4 elements as a list. Okay, so basically taking a list out of list. So that's the idea of the parts in the Mathematica. Now there is something very interesting. It is not just applicable on the structures like this list, like these curly brackets a comma b comma c comma d. This part function. In Mathematica, can you tell me how do you define a function? For example, 1 plus x plus y, right? 1
Yes, sir.
plus x plus y. How it is basically defined? So if you go to the documentation, let me show you something very interesting. which you might not have noticed in this.
Hmm.
So in Mathematica, every structure of the everything is of this form. F of A comma B comma C and so on. So basically structure of everything that is written in the Mathematica has to be of the form function square brackets with a sort of the list. So can you think of something how 1 plus x plus y, what kind of structure it would have in the form of this? Just take a guess and then I will show how does this have this kind of form. Just take a guess. How can it have a structure of f of a comma b comma c? Any guess? It's basically what? Addition
Like,
of three
hmm.
elements, right? Addition of three elements.
Three.
So basically, you can say it's a add function and 1 comma x comma y, right?
Yes,
So
sir.
in that way, it would have the form and you can find this kind of form using a function full form. Let's see. If I do this full form of 1 plus x plus y, what it would give me? Plus is a function 1 comma
Hmm.
x comma y. Let's try something different. For example, full uh full form, oh, just a second. Yeah, full form of, for example, I take a multiplication function x into y into, let's see, xyz. How I'm not sure what it would give. So it took it as just one thing. But if
Yes.
I sorry, if I do full form of x multiply y multiply z, what it should give? Any guesses? Hmm. Look at this. Just guess from here. For
Times.
it should be a times function, right? So times x, y, z. Now, if I apply the part thing over here, so for example, basically, 1 plus x plus, oh, sorry, 1 plus x plus y, I would take, let's say, second part. What it should give me? Guess?
Sir, 1 plus x plus y.
No, the form of
X.
this is, it should be x.
Hmm.
So what I tried to say that this part doesn't only work with the list kind of thing, it also works with the expressions. Okay, so that's
Yes.
what this documentation say. So what I'm trying to say, you have to go through every part of this documentation very careful to get the hang of this language. Is that
Hmm.
clear?
Yes, sir.
So let's say you go to this length. Just quickly go through all of these things. So length of this, basically length of list. We defined the list before. Let's try this length function. So how do you do it in Python to find the length of an array? Do you remember anything about
Yes,
that?
sir. From C plus plus, I do remember.
Okay, okay. So let me tell you from Python, you put function len.
Hmm.
Okay, so that will give the length of that. So here it is doing the same thing, but it's just that it's a different name. So length of the list is 4. Okay, so similarly, you can go through this association thing, like what this association is. Um, yeah, the main idea is to basically solve the last year problem, which we will do,
Hmm.
and that would be very quick. But let's before that just try different things so that. Okay, so association is what? Basically, you want to associate some values to some kind of things. It could be strings, it could be any number, it could be anything. So
Yes.
something you want to associate some. So how do you define association? The syntax for that is the this symbol with this. So for example, I want to associate one to letter B. So
Hmm.
it would be this. B is 1, Okay. Then I want to associate 2 to uh, A, and let me associate 4 to D. So you know, right, how I'm putting all these symbols.
Yes, sir.
Okay. So if I do shift plus enter, that is basically the association I have defined. Now there are different functions of association. You can convert it into list by doing normal of the this association. Let me copy this. What will it give? It will change the association to list. Okay. So it has three elements which are nothing but the associations. Okay, now you can apply the maps on the association as well. What is map? It is nothing but it is equivalent to a function. So basically, you have to apply some sort of function to this. For example, if I define map onto this kind of association, let's say map is F, and this is my association. What will happen? So that map will be defined to the values to which that has been assigned to the elements in the association. So that map would be only defined to them. So basically F would go to 1, 2 and 4. Let's say. So now the B is mapped to F of 1, A is mapped to F of 2, D is mapped to F of 3. Okay. And then sort function. So you can clearly see what is sorting doing. Just look at this and the output. Tell me what the sorting is doing.
Sir, first taking up the values and then like
So it is
arranging it.
sorting the association based on the values which has been assigned to the elements of the association. So basically, one C associated to one would be the first element, and so basically you sorted the association based on that. Now this is something called select. Now select is what? So select is basically selecting it based on the condition. So this thing which you are seeing here is hashtag greater than 3 and is nothing but condition. So it basically select hashtag is basically the number. So for the values which are greater than 3, it would basically split the association into those values. So if you can see, it's A associated to 4 and D associated to 5. They would be part after you applied this select function. Now, what is the total? Total would basically add up all the values in the association. So it's very simple. So my idea was just to give you the quick, uh, you know, so you can go through all this stuff. There's a functional programming. Let's look at the functions because that is something which is important. How you define the functions over here. Because just a second. Yeah, functional operations. Okay, let's look at the map. Okay, for example, let me go through a zeroth assignment. Because with along with the assignment, you'll be able to understand well. So these are the last year's assignment. Okay, yeah, fine. So right. So if you look at this problem, the data shown below for the y equal to fx is best approximated by. So we have to find which function best describes this. Tell me, how would you find it? How many n number of ways are there to solve this problem? Anyone?
So the first basic way is to feed in the values and plot the feedings.
Plot
And then
the
relating it, yeah, like we just plot it,
that
y values
that
and x
that can
values, and
be
we will relate
that.
it. But that is going to be too lengthy. So there
That's
must be some other
okay.
method.
So that's okay. I mean, so what you were saying, you plot this thing, right?
Yes, sir.
So what I would do, I would just use a map function and I would define a list which is the x values. Okay. And when I apply the map function, I would get the y values. So I would chain the function for the one which for which the values are close. That is the best fit. Okay. That's the simplest way. But ideally, what you would have to do, to do this. You can do least square fitting to see what is the
Yes.
function it should approximate to. But even that is not a great idea only if you define the function in this form. Okay. Otherwise, you can see the Taylor expansion of this. And now there are many n number of ways. So let's do this. So first I will define a list. Let's say x. Okay. So these numbers, let me put it 0.25, 0.5, 0.7, 1, 1.4, 2, 2.4. Okay, so many numbers. 2.4, 3.1, 3.5, 3.9, 4.2, comma, 4.6, comma, 5. Okay, so this is the list. Okay, so let me just give you ID. Okay, fine. This is the list. Fine, we have the problem now. Let me hide this. Okay, so how would you basically do this thing is, so there are many ways on which you can operate function on this. Um, Let me change this to some other thing because x I would be using for the function. Okay, so you have to apply a function on a list. So let's simply do this. So there, this is the simplest way. For example, I want to apply 1 by x square plus 4 on the list. So there is this way, backslash at the rate list. If I do shift enter, that would give me the, well, okay. So what happened? What, um, so at the 0.25, it gave me this. No, I think we used the wrong syntax. Let me do it in other way. For example, I use function command, function for, then let's do with the simple first, x, comma, 2 times x. Let's take the double of this and I apply it on the list. Ha. So see, the function command, basically you define the function and apply it on the list. What it gave? It gave me double of everything, right? Whatever list I gave. Is it clear?
Yes, sir.
Okay, so now what we have to see which one is the best out of it. So what I will do, I'll just change the things over there. Divide by x square plus 4. So does it look, the first value is not at all same, second is close, third is not at all. So I mean this doesn't look like a good fit. Let's change the function to the second one. Log. How would I define? What bracket should I use when you define the function? Should I use these brackets?
No, sir. That curly ones.
Square. Square for the
Okay.
function.
Yeah, sorry. Square
Okay.
ones.
So that's okay. You're learning right now, so it's okay. So 2 by, there you can use this bracket, which is okay. 2x square. Okay. So let's do this. It is okay. First number is good match. Second is not at all. Third is not at all. See, this is not a good way because ideally what you should do, you should find the deviation error of these values from the values which are given. And the for the one which the for which the norm of that deviation values is the less, that is the best fit. But we can clearly see it doesn't look like a good fit at all. Even the last values, they don't match at all. Okay, let me change it to the this one, e to the power minus x minus x log of 1 plus x. 173, okay, 245, 263, 254, which is 258, 215, 20905. So this looks very much close, right? If you look at the numbers, I mean, it's not exact. They asked which is the best fit. This is much, much better than what we had earlier. They were not at all matching. If you look at every number, it is within the error of 0.03 max, I guess. Okay, 0.01. So 0.11, 0.11, 0.063, 0.058, 0.045, 0.046. So this looks like correct to me. And they also have said that this is the correct, but let's try 1 by 4x for the time being. Okay, they should give worse. Yeah, this is not at all yeah, matching. So
Yes.
yeah, so C is the correct option. Is it clear? So this is the way you can find the best sort of fit. Now there are many ways of doing this problem. Okay, we have this problem. Let's try to incorporate different possible ways to solve this so that you get the idea of the syntax over there. So I'll go back to the documentation again. I'll go back to the core language. There was this language overview, functions, map. So if you see, they say these different kind of thing. Okay, let's do this kind of thing. So you define the explicit function first, and then you map it to the list. Let's try this. So this is basically, so I will define the function as 1. In place of X, I would use the hash, sort of hashtag kind of thing. Right. Let me try whether this works. Okay. Let's see if it works. And this is a very complex. The easier one was using the function. But let's do for the sake of seeing what happens. Okay, what happened here? Can you see? So you had a
Yes.
list. You said this hashtag is basically replaced by every element of the list and you give 1 plus that. So our first element was 0.25, it added 1, it became 1.25. Then it became 1.5, so that's how it gave us everything. Now let me change it to the way the function is, which was correct. So it's like this. I just want to see whether this works in all possible cases. It should. It's weird, but yeah. So try different things and that's how you'll learn the things work. Yeah. Okay. So this should give me whatever we got using the function for the same thing. Uh, it didn't give, oh, there was one, sorry. Yeah, I was like, why it is not matching. Okay. So it is same as what we got from there. If I use this thing, let's try it over here again so that you get the hang of it. Log 1 plus x. So both are the same thing, but they are done in different form. So this sort of idea is basically defining the function explicitly, as in the you say this is the functional form. There is one more interesting thing where you can define function as a operator. So this is one of the thing, yeah, which is one can use a map operator. Let's try this. So map, okay, 1 plus hashtag. Okay, I'll apply it on the, let's say, list. Oh, it is not. So it is basically F applied on the list element. So this is not the right way. So first you should define the function as operator. And how can you define the function as operator? That there must be something. Let's check using the map. If I do, let me try this as well. I want to try this. If I do this thing, what it should give. Yeah, this I am not able to understand why it is giving like this. It should not have. Let me put and. Okay, that is same thing. Okay, so that's fine. So you understood these two ways, right? The
Yes, sir.
basically how you apply function on the list. These two should be enough for solving the physics problems in the vicinity of our scope. Yeah. Basically, you can go through these and figure out what the other issues could be. Okay, so this is the function. And then let me see if you can have something related to the visualization, which is the graphics, data visualization. Let's do that. So list plot you must have studied, right?
Yes, sir.
So what does it do?
So it basically makes the graph, the bar graph and the line graph.
Okay, yeah. So so if I just do this thing, let's say x comma x between let's say what should be the value should I be giving? Let's say 0 or 1 to 10. What it will give? Let's try this. Is it even valid? I'm just trying. Okay.
Oh, that.
Sorry, that's not the syntax. Yeah. So whenever the issue is when you don't remember the syntax, just go there and see what the thing could be. Okay. So it basically has to be list in the argument. So
Hmm.
I basically let's say this. Even I think this one range I have to put, yeah. So let's say number from 1 to which is using the range function from let's say 50 I put. So basically what it will do is it will plot the number from 1 to 50. Okay. Now if I want to do the square of that, how would I do that? Okay, if I want to plot
Sir,
x
yeah.
square, what will you do?
Sir, put up like curly brackets.
Which curly brackets? Okay,
Yes.
then
Then put x to the power 2.
x to the power.
2. And
Okay.
then close it. And then
Uh,
comma. And then again open the curly bracket and define the range of x like output, yeah, from if it is going from 1 to whatever.
okay.
Range functions are I don't know explicitly, but the range is defined in this manner, so let us we
Are
can
you
remove
sure this
that.
will work? Let's see.
Yes, sir, like I have seen this in the videos.
No, this doesn't work. That works only when you
Okay,
are doing the
yeah,
continuous plot. So that's what I
okay,
wanted to tell
continuous
you.
curves, get it.
This works. Okay. But
Hmm.
what if you want to plot discrete values? What you would have to do? I just told you how to define a function on list, right? So basically
Yes.
what you would have to do is function, you have to basically define x, which is x square function, and you define it on the list. Let's say our list was old one, which we defined earlier.
Hmm.
So it gave something discrete values, and the list was 0.25, 0.25. Oh, so list was 0.25 and all those numbers. It found the square of that and plotted is from the one as a function of the length of that list. Basically, for one, it gave the value 0.25 square. For 2, it gave the value point. What was our list? Yeah. What was our list? This one. For 2, it gave the value zero point 0.5 square. For 3, it gave the value zero point 0.7 square. Okay. So it plotted it. Now, there is something more interesting, which I think I should tell you because you guys must not have gone through that. So it's equivalent to Python. Like, how do you want to, how would you basically modify the list and all those stuff? For example, you want to change the value of the, for example, you have this list and you want to change the value of second part. So this way, what I am doing there, I am using the part. Okay.
Yes, sir.
So second element I want to change to, instead of zero point 0.5, let's say I want to make it zero point 0.9. I'll do this. Okay. Okay. Now let's print list. It's just like the print. So print list. So you see the second element has been changed to zero point
Yes,
0.9.
sir.
So what I'm trying to say, it's nothing is different. It's all the matter of the brackets, the words which you use over here and there, that is different. Okay, so that is one thing. Another thing, how can you, and let's say you want to see a function and you want to sort of animate it as a function of a parameter. How would you do that?
Sir,
Have you been
manipulate function we have seen.
okay, right? How do you use manipulate function? Manipulate.
Manipulate, yeah. And then like all the other things were quite similar. Like the whole syntax we should put it inside of the
For
manipulate.
example, okay, tell me how would you plot the normal distribution? Which is, can you first tell me what is the normal distribution? The Gaussian function. What is the function? It's
Uh,
1 by square root 2 pi sigma a to the power minus x square by 2 sigma square, right?
yes, sir.
So here sigma is the parameter. Now
Hmm.
I want to see if I want to change this sigma from a particular range to for particular value to another value, how
Hmm.
would my Gaussian change? That's a very interesting problem. You
Okay.
must have studied a free particle evolution, the wave packet evolution in the quantum
Hmm.
mechanics, right?
Yes, sir.
So that's something one can study.
Sir.
You solve the
Yes.
problem, the quantum mechanics mein you get a function, you get a very complicated function. You want to see how the width is changing. Then you can use mathematics over there. Okay, let's do that. So how would you do that? Here,
So,
you
yeah.
don't have to define the function because it's a
Hmm.
continuous thing. Okay.
Hmm.
So for example, I would go with exponential first. You can put the curly brackets or you can't, that doesn't matter, I guess. Yeah. X square pi 2 into sigma. Let's see, sigma. We'll define the parameter later. Square. Okay. Then I define this thing. Let me put a bracket because I mean, otherwise it's okay. Yeah. Square root. How do you define square root? Okay. This thing 2 into pi into sigma. So you have a function in the form of sigma. And is there some bracket missing? No, it's fine. So you have a plot function. Now you want to plot is at as a function of, let's say first you want to plot it as a function of x for a particular sigma parameter. So that x has to come within the plot command, which is basically, so x, let's say I want to plot it from minus 100 to 100. Okay. So let's close the plot function box. Now we manipulate the parameter. For example, I want to manipulate sigma from, let's say 1 to 20. Let's try. Okay. Then I close the bracket for the manipulate. Do you think it is correct?
Let us try it. Then there is alternative, I
Uh-huh.
think, for it.
Yeah, yeah, yeah. Okay, let's see. I hope this is correct. Why is it taking this much time? Oh, no, something is wrong.
Yeah. Sir, I think
So,
last syntax sigma 1 comma 20.
uh, I don't think so.
Okay.
That should be okay. Um, we close this bracket as well. No, I think, yeah, yeah, that's the issue. Okay. No, no, that was not the issue. Okay, so it always happen when you try to write a complicated function. Let's remove it. So let's say sigma times x. Let's see. This is something we can visualize simply. Okay, so you see this worked. That
Yes, sir.
means what was the issue? Issue was while we were writing the
Okay.
this yeah.
Complicated function.
Yeah, let's go back and see where we made a mistake. Minus x, x
Okay.
square, 2 square, is the square root fine? 2 into pi sigma. I hope this should not be an issue, but
Sir, just check the bracket curly ones 1, 2, 3, and last it has started with the 3 bracket, but in the ending we have 4 close bracket.
this one, oh, this thing.
No, no, here, sir. Like the that yeah.
No, but okay, let's remove this. Yeah, even then, it should have minus x, this bracket close like this bracket close like this with this, square root 2 pi. Okay, minus x square. Uh-huh. Yeah, and sigma from 1 to let's 0 to 1. Nice. Something is,
Plot range. Can you put that?
yeah, but that maximum value has to be 1, right?
Yes,
Even
yes.
for this, because this is a, are we putting the form correctly? A minus x square. Uh, how could it be? Let me try. Let's go with the Lorentzian first. Then we maybe see. Um, E minus E. Let me go with simple Gaussian. Minus x square by sigma square. Matlab we are doing here only wrong.
So
That's,
instead of sigma, can we use another variable?
I mean, that should not be issue, no? But yeah, let's
Yes.
try. Uh-huh.
Okay. No, sir, that is wrong.
So so E bracket should not be an issue. Never. I never thought it that way. Let us try plot range, whatever you were saying, plot range, where from 1 to 1, right?
Yes.
Hmm. 1 comma 1. Why is it saying this is wrong?
Plot range can be written in a plot function.
In?
Plot
Oh, yeah,
function
yeah, yeah.
where
Sorry, sorry.
I
Yeah, yeah, yeah. You're right. Plot range, it has to go within that. Plot range minus 1 comma 1. E has not, okay. We removed the bracket accidentally. So basically, one thing I'm sure is we are defining this function wrongly. That's the only thing I can think of. Right. But why is it wrong?
So exponential exp can write like that, or
No, I mean you can try this. That is okay. That might work, but E should also work, no? Let's try this. This should work. Even this is not working. Oh, it was just
so
work.
working.
Oh, it was working. Let me change it to E. Why it was not working before? Okay. E should give same thing, no? Oh, what is happening? Uh, E minus array. Okay, sorry. Yeah. Yeah, I think it was also working. We were not in the correct regime, right? A.
Yes.
So that was also working. So you can see the basically the manipulation of this. Fine, fine, fine. So this works. I think we just didn't the initial thing was zero. Yeah. So zero is what? Zero is basically infinity. It would give the infinite width to the Gaussian. Okay. So yeah, we didn't move the parameters. Okay. So this is fine. This is how you can use the manipulate function and you can animate different sort of functions using this. Fine. Let's say, so there are these table features. I hope you must have gone through these as well. Table.
Don't think it came in week one lecture. Might
We
be it
didn't.
should be in upcoming lectures.
No, I don't think these. I think these are for you to study now because these things he might not be teaching in the coming lectures if I see. So let's just tell me what is the basically thing. Why do you need the table? So for example, for the linear algebra stuff, you need the matrices and all these kind of form. So you can
Oh,
use this table
hmm.
sort of idea to get that matrix form, something like this. So yeah. I hope you can just go through this, or do you want me to do some of this? Let's try and understand because by doing things, your mind will remember what the things are. Okay, you can just copy this. Why waste time? And let's see what does it do. So it's basically key from I from 1 to 10, it is finding the square and it is giving us the list of that. Okay, if you want to do it in the steps of 2, it's equivalent to np.arrange. In Python, if you're familiar, numpy.arrange is a function where you can write the numbers in such a way with the particular gap. So 0 to 100 in a gap of 2. Let's say I 0 to 100 in a gap of 5. So it will give me the squares of all those numbers. So first is 5 square, then it's 10 square, then it's 15 square, then it's 20 square. Okay. So this is sort of equivalent to numpy.arrange. Okay. Yeah, so this also you can do x. Basically, it's x and it's repeating the x because we haven't defined values of x or something. It's just repeating x 10 times. Now, if we want to write a any matrix out of it, first we will write it in the tabulate form, then we use the matrix form function. So let's say, so you want to write it as 5 times I plus 2j, and I want to include I from 0 to 3 in a gap of zero point 0.5. I want to include j from 0 to 4 in a gap of zero point 0.4. I'm doing something random, let's say. Okay. Yeah, so it's a big matrix. Let's, because a gap of zero point 0.5 gives the 6 dimension over here, and gap of zero point 0.4 gives more dimension over there. So let's do the matrix form of that. Matrix form of percentage, because it's already there. Yeah, so it gave me the matrix. Okay. So yeah, you can print the columns and all those stuff. Fine. Okay, there are many things which you can do. Okay, so let me try to plot vector field. So how do you remember how you plot the vector field? Anyone? You can say. You just have to, be familiar with the syntax. How, what
This
would be the
vector plot, I think it was.
It was wet. So basically, yeah, it is very simple. Plot, you want a list plot, you want a line plot, you want what kind of plot, stream plot, any plot. So you just put that word before. And if you don't
Sir,
remember, it will give you a lot of list there. Vector plot. If I want to see, let's say I don't remember, I go there. I info, and that will give me the syntax. So it says vector plot generates a vector plot of vector field Vx, Vy as a function of x and y. So that's pretty simple. For example, if you want to find a vector plot of a function xi plus yj, what you would have to do? So your Vx would be x, Vy would be uh, j, then x I want to say, let's say from x min from -1 to 1, and y I want to say from -1 to 1. So that's simple. It will give me the vector plot of xi plus yj. Okay, tell me what would be the curl of this? Will there be any curl?
uh, no, sir.
Why? I
Sir,
mean, you can find
yeah.
the curl by taking the determinant del by del x, del by del y, del by z, z, and that. But in simple way, you can't see anything which is curling
Yes, sir.
around.
Exactly,
But
sir.
what if I do, let's say this? If you solve this analytically, you will see it will have curl. And also you see this function also have a curl, which is this rounding motion. So it's non-zero. Okay, so you can basically play a lot of physical things by this kind of stuff. Okay, let me change it to something called stream plot. Did you get a chance to look at this?
Yes, sir.
Okay, what does it do?
So
Let's see.
basically the same kind of a plot, except at zero, it also,
Okay, let's see.
yeah. So where there lies singularity or undefined value, there also it puts a line.
Huh. So it basically gives you the direction. That's the not the magnitude, because all the vectors, if you see, they are same, right?
Okay, yeah, magnitude,
Yeah.
Hmm.
So that's the I think that's the idea. So the stream plot would um, give you the direction. It gives the direction only. No, let's
No,
see.
sir. Yeah, in the
Let's
lecture it was
do.
said it only takes care of the length, like it does not takes care of the length of arrows. There will be arrow.
There will be arrow, right? Yeah.
Yeah.
So it cares about the direction. So you see, I put it two times this. Direction changes, but the arrow is similar. So it doesn't take care about the magnitude of the arrow. It's just the direction. Okay. So this is one of the thing you must have studied. Have they taught you the solving equations yet?
So, like what kind of equations?
Just like polynomial equation, let's say. Uh,
Sir, Yes, sir. I think yes, there was polynomial equations.
Just a second. Ek minute. Let me see if we are getting recorded because that's important. Yeah. Okay. So yeah. So how would you solve the equation? Any idea if you have solved it?
Yes, sir. So
Okay, let's say
the
you don't know. I know
Hmm.
how do you solve? It's using nsolve. Let's say you don't know. I'll go to the documentation. I'll go to symbolic and numerical computation. There is equation solving. So everything is there. Okay, there are many ways. There is nsolve, there is solve. So let's say go to this nsolve. So it attempts to find numerical approximations to the solution of the expression of equation or the inequalities. Basically, it could be sort of the linear computing which you use to programming. Do you remember the chapter linear programming in the NCRT curriculum which you used to do, where you used to have inequalities, right? And you used
Yes.
to plot a region which is the solution to these inequalities. So that's the kind of thing it can also deal with. It's the inequality. So, okay, so this simple thing, let's say I copied this. What is it doing? It's basically a polynomial equation x to the power 5 minus 2x plus 3 equal 0. So here you put equal twice. And this comma x means I want the answer to the x. If I don't put this, that would be wrong. So you have to put this x over there. So if I return this, it will give me 0.25 is not a valid. Why so? Let's do this. Okay, what is the issue? I just copied it from here. That should run. Mm-hmm. Let me write it by myself. N sol. Let's say simple. It's basically if I write 2 times x minus 1 equal 0, comma, I want x. Yeah, it 0.25 is not a valid variable. What does that mean? It should not be doing this. That's very weird. Point did I see. See, that's the issue. Um, I think we already defined the x somewhere. So let's change the variable. Maybe that's the issue. It looks like to me. Huh. So see, I already defined a list with x before. So you have to be very careful. You got it right? So that's why it was not working. So I changed it to y, and it gave me this solution. So let's say you put a random equation, something random. Let's say x to the power 5 plus 3x to the power 4 minus 2x to the power 3 plus 10x to the power 2 minus x plus 3. Let's see if this, what does, sorry, I should have put y. Or I can start a new notebook. Or there must be a way to delete that as well if I want to delete a list. Okay, let's solve this. Okay, so what did I get? This is the real, this is complex. So anyone, why do you have the complex? Because this is the simple polynomial equation theorem. Like the complex conjugate has to be occurred in pairs, right? If you see this, the other one is the complex conjugate. If you see this, the other one is complex conjugate. So you have 5 solutions because it's a fifth order polynomial and you easily solve this. This you can't just solve by hand, right? So that's where you can use this function. Now, any idea how would it work if you want to solve it for a couple of equation? Like you have variable y, you have variable z. What has to be done? So for example, it's a system of equation 2x plus 3y is equal to 5 and something else also. How you would do that? Just a guess.
Sir, we can write comma the another
Yes,
variable.
yes. So first we will write two equations in these brackets. So let's say 2x plus 5y is equal to 5. It may not have solution as well. Let's say z and 3z minus 2y equal 1. Okay, z comma y. It will give me both values. Okay. Oh, yeah, sorry. Huh. So you get two solutions. Okay. So let's say I put power over here, square and square. Oh, you get another pair of solutions. So there would be 2 to z. So z would also have. So there are how many solutions? Four solutions to this equation. Okay. So yeah. So basically, and there is one more thing. Let's say I want just the real. I want there should be just real solution. I'll put real and it will give me nothing because there is no real. Real is not a valid option. Okay. It is in Python. Reals. This might be the correct thing. Yeah, so this is the solution, the real solution. So it gave me just the real solutions. Let's say there is complex also. Complex. Hmm. It gave me the complex is not a valid option. Then what else will be? Complexes. Huh. So complex. See, I don't know this, but then I searched it. It's already there. So that's how you can, with time, you'll get familiar to this thing. So it gave me the complex solution. No, we didn't compile it. Yeah. Shift plus enter. Yeah. Complex is so if you see this, it also included the reals in the complex because they are also sort of complex. Yeah. So that must be the reason. Okay. So this is one thing. What else can be done with this? Let's try solving some. So I'm not sure if it will be able to solve these kind of things. Let's say, e- hello? Yeah. Hello? Hello, is someone asking question? Yeah, who is asking? Can you okay, there was no, it might be just a disturbance. Sorry about that. So,
Sir, I just have a like query that
okay,
I would
okay.
like to.
Yeah, yeah.
Sir, I don't know like whether like I'm framing it correct or not, but
That's okay. That's okay. Just
yeah.
ask
So
because even I
Wolfram.
might not know. Yeah.
Hmm.
Okay.
So see, like I'm teacher.
Okay.
So how this language can help me? Because my main motto was to to understand. Like I teach physics, so I
Hmm.
wanted to make physics little bit easier and more interactive for the student. Then I saw this course and I then enrolled in.
Yeah, it's very helpful. So, Abhi, I didn't move to the problem solving part. Let me give you a
Hmm.
simple example where it can be helpful. Okay,
Hmm.
let's see this week one assignment, and there is this assignment because my main idea is to just solve the previous year things and see
Hmm.
how it is helpful. Okay. So yeah, so let's say this is some sort of vector field. Now in physics also you can have some sort of velocity fields, right? Now if
Yes, sir.
for example you take example of the magnetic dipole. or the electric dipole, and you always draw the electric field lines around it, right? And
Yes.
people so let's say what students would do, they would just see ki from the negative to positive I can draw the field lines like this. But how they would exactly find that, how the field lines would look, would be if they have the expressions from the physics point of view, or you derive the expression, you derive the expression of the potential due to dipole, okay, v of r. Then you ask the student to plot the field lines of this, then they can use this Mathematica. So they have the expression of V of R as a some field as a I comma j. Then they can put these expressions in the vector plot, and they can plot and they can visualize those things. Or for
I
example,
see.
this thing. So that's how you can make it useful in physics. Like for example, you have a Leonard Jones potential, which is the potential which occurs in the you know the when the atoms are close enough, and that's the some sort of force which is opposite to this actually. So
Yeah.
you can ask them to find the minima of that, not by deriving, not by doing the derivative test, but by using the Mathematica. So these could be
Yes.
some simple exercises where you can use the physics,
Yes.
and there are many more actually. So for example, you have a harmonic oscillator. So for if you want to, they want to plot the solution, exact solutions of the harmonic oscillator, which are Hermite functions. There you can use this thing, and I mean there are n number of things for the solving the eigenvalue problems. You can so for eigenvalue problems, let me give you. I think they might teach you in the next part of the course, but there is, so idea is to go through the documentation. Let me show you where it can be very useful in physics.
Yes.
So symbolic computation, equation solving, matrices and linear algebra. Most of the physics involve matrices and linear algebra. So it's basically you go to this, you can use this for the QR decomposition. Basically, that's equivalent to solving the eigenvalue problem. So yeah, so you give something which is physical matrix you get from a problem solving, and it's a complex matrix they can't solve, let's say. So then there you can people they can use this kind of software or coding to get the idea of the physical numbers, which might give them some sense. So that's
And
the
sir,
idea. Hmm.
yeah. Also, I saw like there is something AI enabled in it, and I
Yeah, yeah.
was like,
You can go through this there. Yeah, it might not be done in the course if I am not wrong,
yeah.
but yeah, neural networks and all these things you can go through them. Even in Python, people use the tensor products and all those stuff. There are many models for the machine learning over there as well, different packages, so
So
one
that
can
means we
use.
can essentially create a software, like kind of a small software to make
Not
teach.
software, software is already there. So the point is you can do it to basically train your data. So it could be some data related to a problem, and you can use the machine learning, and then you can come up with some models using that. Yeah.
Okay.
So there also it can be used. Yeah. I mean, I use Python mostly for those tasks, but one can use this. So let's say, let's try whether this work with such sort of functions is equal to x equals 0, comma, x. Just trying to say whether it works. Yeah. It's okay. Sorry. Why did I define x before? I should not have. Okay. Yeah. Hmm. So it is saying it's a complex solution. Always. There is no real solution. That is weird because if I plot e to the power x and e to the and y, they do intersect, right? Let's see that. Let's plot these two functions. Plot x x exp x, and I want to plot it for, let's say, x comma minus 10 10 as of now. Oh, they don't intersect. Yeah, then it's fine. It would not give me the, let me see, minus y. Okay, they do intersect. Let's run this. Is it 0.56? So this is the one real solution. Reals. So I think this is the correct solution. Let me one. Okay. Hmm. Yeah, so this is the number which you got from nsolve, and even with the plotting, you can see this is the point where these two intersect. Okay, so this is the kind of things you can use. Now, why do we need this? For example, if you remember Wien's displacement law, anyone, I mean, you guys are from physics background, right? So you must remember that law, right? So there, once you solve this equation, you get equation sort of this, and to solve that thing, you can use this, and once you solve that, that number will give you the Wien's constant. Yeah. So it can be used in various problem of the physics. Is there something else that is left which I should do? I think that's enough. Now we can go to the problem solving thing. Let's see. So that because you would do the assignments, so this is how you should do. Uh, just a second. Let me open the other window. Ha. So this is the assignment. First is the thing I want to find the 100th digit in the square root of this. Okay, how do you find that? That must have been discussed in first assignment. Anyone? Anyone? How would you find that? Pi by 2 square root 100 digit. What would be the 100 digit of that? Hmm. Is anyone there?
N square bracket,
Okay, yeah.
n
Then,
square bracket root of pi by 2,
okay, by 2. Then,
comma 100.
comma 100. Hmm, perfect. So that is the 3. So the 100 digit is 3. Fine. No, so that's a simple. If I don't do this, what will I get? I'll get just till certain order. That's not the precision we were interested in. Okay. So next question is the curves y equal to x6, y is equal to e to the power x minus by 6. Do they intersect or whatever the thing is? Now tell me how how many ways I can solve this thing. If you have this curve and this curve, to see how many times they intersect or whatever they do, what is the easiest way to do this? Anyone?
Mathematically, we equate the two equation and find the x.
Mathematica? What?
Mathematically, we can equate the two equation
Okay,
and the
yes.
x.
So let's do that. Now and solve. Using and solve, you mean, right?
Ah, yeah.
Yeah, so I'll do this thing. X by 6 minus x to the power 6. Okay, equal 0. X, but I want the real solution because that's what you see on the graph. So let's do this. Oh, okay. Sorry, Y. I don't know how to delete that earlier array. Okay, so there are three solutions. So it intersect basically three times. Now one could have also seen it by just plotting these two functions, which is x to the power 6, comma e to the power e to the power x by 6. Let's say x from minus 10 to 10 first. Then you would have to actually make the guess of the range. So first you start with this. Okay, wow, interesting. This is something wrong? Y6, y power 6. Let's do 1. Okay, it intersect at minus 0.91. Okay, that's the one place. Let's go ahead. 1, 2, 3. So it intersect, not too early. Um, yeah, so it intersect at this point as well. Then I can change, but then I basically I have to look at a very large range to see if something happens. Let's say 100. I mean, we already know from the n solve, but let's not go there. 200. Oh yeah, see, it's going over there. So basically, let's say now there is a thing of the range. I want the plot range to be much larger. Let's say plot range uh goes to, it's that big of a number. Why don't I plot log of this? That would be better. Log. I mean, in the x, they should intersect at same point. Hmm. So you see, it intersect as 188. So you see something, there was no point in plotting the x to the power 6 and e to the power, because those were increasing like two large numbers. So in those cases, it would be better to plot the logs. Then it's very nice plot, and you can see it clearly intersect at 1 to the power 80, 188, something like that. Okay, so that was one way of doing this problem. What is the next question? The smallest value of x for the point of intersection of this is what? I think again you can use n solve. I don't see anything complicated in this. Log of y. So this is the first assignment, that's why it's very simple. Otherwise, the last assignment would be random walk. That is something which is very interesting and I really love. So that would be fun exercise, and I would try to bring out some interesting problems for that day. Okay, there is no solution. Log x. Oh, sorry. Y. Yeah, there are two solutions. So this is the smallest one, 4.17708. So see, if you are using the Mathematica, you have to be very precise. Now, if someone have asked you in entrance exam, you could have chosen this as well, because there you would, you solve by guessing and all. You don't go to this much precision. So that's where Mathematica helps. You get exact precision of the number, which is the correct. Okay, asymptotes of quote hyperbolic inverse. Okay, how do you write quote hyperbolic inverse? Anyone? Anyone? See, you would have to speak up if you want to learn this. Arc, arc, You call it normally arctan, right? So arc, chord, chord, hyperbolic. You don't need to know actually. Everything is there. X. Let me plot it from X. Let's say minus 5 to 5 as of now. Hmm. Okay, I see a this kind of thing, which is asymptote over there. Let's take to confirm it. Let's make the plot range to be from minus 10 comma 10. Okay, so this is clearly an asymptote. Yeah. If I go from, yeah. Right. So the y x equal to minus 1 and x equal to 1 both are asymptote, and y is equal to 0 is also asymptote. So is the option B clearly. For function this, the distance between two consecutive 0. Okay. Okay, tell me this. Do you really need to use Mathematica for this? Question number 5th. Anyone? Is anyone there? Speak up. No need to be shy. So this problem, this function, do you really need Mathematica for that? To find the distance between two consecutive zeros. Basically, the points where this function intersect the x-axis. Those two consecutive points where they intersect at the x-axis, what is the distance between them? Do you really need Mathematica to find those points? The answer is no, because it's a continuous function, this whole thing, right? It has to go in some sense. It has to die down, right, with this exponential. So the only thing which would make it cross to 0, and this will never go to 0, okay? It will in the negative side. But if you see this cos r by 2, so cos r by 2 is something which intersect the x-axis. And cos r by 2 has a periodicity of what? Anyone? Simple physics, maths. Cos x by 2. Cos x has a periodicity of 2 pi. So cos r by 2 has a periodicity of what? 4 pi. Okay. So now for a 4 pi function, the cos would look like, okay, let's just do it. First, I will plot cos, 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 okay, cos r by 2 from r 0, comma 20. Let's say, hmm, okay. So if you see the two zeros differences, it's around 6.28 because this is 6 and then 0.28. So that is 2 pi. So 2 pi is the distance. But if I put this weird function around, it would still remain same because that is something which is deciding the zeros in this function. So you don't have to, but let's do it for the sake of doing it. Log 2 plus r. Okay. There has to be multiplication. We should put. Yeah. Yeah, so you see, this is a dying function, but the distance between them is 6.28 only. So that is the distance, which is 2 pi. So that's why the option 2 pi is the correct one. So yeah, if you look at the sixth problem, here you have to plot the vector field and see which is the correct vector field. Right. Let's just do this. So x square plus y square and x square minus y square. Vector plot. x square plus y square, comma x square minus y square. And I want to plot it from -1 to 1 in both. X minus 1, 1, y minus 1, 1. Okay, which one looks the similar? So now, see, in order to get exactly what they have got, what you would have to do. Now we can actually see this is like this and then going like this, coming back like this. Then it is going like this. I think this is the C option. Yeah, C is the correct option. But in order to exactly plot the way they have done it, we should write this command. So it has to be, you have to basically, you have to look at the frame label and all those stuff in this. You can just go into the documentation of this. So uh, let's see what else are the arguments to this. So, right, plot legends, fine, I don't care. Vector markers, no. Plot layout, no. All, none. Scaling functions, what all other properties it has. Hmm. Yeah, so the other things are basically the how you have to access styles. Okay, that's what they have changed. So basically, I think one is the frame label that is has to be adjusted in order to get the exact image. But you know, it is very clear that C is the correct option. But you can beautify this using these properties. You have to go to this style. Yeah, frame textile. There are many other things. Yeah. Presentation. Yeah. So this kind of thing you can do to exactly match that thing. Okay. So you have to basically go through these things to exactly match the plot, but we don't need to. Whatever we did was right. Okay. The next problem is about the charge, or you have to just say this is, we know this is like the magnetic dipole. You don't have to do any computation for this. It's very clear from north to south. Yeah. This is also not a problem which you have to solve. It's just they have given you a equipotential surface and they just want to ask whether the negative charge is placed at one of these points. So it has to be placed at this point because if you see the potential over there, these values are the potential and that is negative over here. So it has to be the negative charge has to be there, which is 1 minus 1 point. So that's why it is D option. Okay. Yeah, this is interesting. So you have U of R as this. Now, if you approximate it as the quadratic potential, what is the value of alpha? How would you analytically do this? Anyone? If you have U of R as this form and you want this value of alpha, how would you analytically do this? Anyone? Speak up. You should. Sarinita, do you have any idea? If you have given u of r, which is of this form, and you want to find the alpha, which is coefficient of the second order term, which is r minus r naught square. How would you find that coefficient? It's a simple harmonic oscillator kind of problem.
Right. Doesn't have a cutoff.
So you find the minimum of that potential, and then at that minimum point, you would find the second derivative. That is the alpha, which
Okay, sir.
you would have. But in this case, there is a that is basically you are finding the Taylor expansion. Now in Mathematica, how simple that is, that you have to just you can give any function to it and it will give you the Taylor expansion. Did they teach you in the class this thing? How you find the Taylor expansion?
Yes, sir.
What function you use?
Just a minute, sir.
Yeah. Mm. So it's Taylor series, right? So it's a series function. If you go look at this, let's look series. So if you see, it's basically any function, you find a power series expansion about the points x naught, uh, where n is the explicit integer. So basically, to whatever order you want to find, you have to put that number as n. So let's put exactly this thing. What was our u? Our u was minus 1 by r plus 2 by r q. Okay, this is our function f, comma, curly bracket x. Okay, our x is r here, and x naught is basically you can find it would be at what point this would be 0. So that is, if you do the derivative, it would be 3. And next is n, which is the second order you want. So it's 2. You want the second order. So that's what you have to do. So see, it gave you the expansion about 3, r not equal to 3, to the order second. So this is our alpha, which is 1 by 81. So I think that option was there in the, yeah, so this is the correct option. Okay, so right. You have to find which is the correct plot out of all these. Let's see that. So I'll plot all of these with legends and all, and then you will see plot. How can you plot multiple plots in a same plot? Anyone? Like this one, I can plot log x into log of x, comma, x from this I plotted, let's say. Okay, but how would I plot multiple plots using plot command? Anyone?
In
It's
case
equal.
of Python, we basically use a subplot.
Yes, very nice. In Python, you use the subplot, and also you can't even even need to do that. In Python, you'll plt dot plot x comma y. You do, then you do another command plt dot plot another function x comma y prime, but with a different color. Then another command. Then at the last you saw plt dot show. So all of these plots will come in the same plot. Okay, but herein you
Yeah,
don't have to write the plot command again. You can just define all those functions in one curly brackets. So let's define all of these options in the. So how would you do the abs function? Absolute. It's abs. Okay, the same thing. Okay, close it. Yeah, next one is e to the power minus x log of x. Okay, Then it's abs again. Mm-hmm. Mm. Sorry. I should put multiply over there. Multiply over there. Yeah. So looks and then close the bracket. Yeah. So all of functions came on the same plot, but it's not beneficial to go to this big range. Let's shrink to 2. Okay, now I plotted all of this. I don't know which function is which color so that I can choose the correct option. Uh, I mean, it looks like to me it's the option.
I
Nothing looks, nothing looks correct. Something is wrong. Um, x into log x, abs, uh-huh, and e to the power minus x log x, e to the power minus x. I don't know if this works like this or it does. Yeah, no, it's same only. It has maxima. Hmm, minus 1 to 1. Uh, x log x. Abs. Are we using? Can you see the mistake over there? Are we doing it correctly, right? They are saying this is the correct option. Let's just
I
plot
think
that.
got it.
Yeah, looks correct. Even I am not able to see what's the issue. Minus x log x. This should give me the correct thing. No, 4. Oh, okay. So yeah, we plotted in a very less range. So that was the issue. So let's go back. Huh. So let's plot in 5. What is the issue? Is it the range that we are not able to? Let's fix the range. Plot range. Um, let's say minus 1 to 1 first. Then we'll change accordingly. Okay. So the issue was this. So in that range, we were not able to see this graph. That was the issue. Now let's give the legends to these. Like what that would be just nothing but because we want to see which color is what. Plot legends. Now what as a legends I would like to see which correspond to what expressions. So this select expressions. Hmm. Okay, so the green one is corresponding to e to the power minus x log x. So C is the correct option. So I guess it is clear, right? So see, even I was struggling while I am doing this. But when you are learning a language, it's when you have perfect documentation, just like this Wolfram has, it's very easy to learn. But for example, the languages which are like Fortran, C++, they do have good documentation, but it's still complicated to learn those. But because these kind of new things have very nice documentation that you don't have to go and see, you can just copy, paste, and do all this stuff and learn it on your own. So yeah. So this was the assignment one from the last years. Now this would be helpful to you in solving the assignment of this year. Right. So you can ask me any questions or drop me an email or something because I am also in learning stage. So we all can kind of learn together. So that's the idea. I hope it was fruitful for the first session, but I promise we'll do interesting things in the later sessions. Yeah. Any other questions? Rakesh and other people, any questions you have?
No, sir.
Yeah, yeah,
No,
ask.
sir.
Rakesh? Oh, he said no, sir. Okay, fine. Yeah. Okay, then. Uh, It looks like we have done a lot for the today. So I can end the session. We can meet next week, same time, 3 to 5. Please try to be there for the next classes because I think then we'll go to different sort of coding. So for example, I would also do solving finding the roots of equation, finding the solving the differential equations using Runge-Kutta algorithm. So these all you must have seen writing in Python. Okay, we'll try to write these things in mathematics also in the next few weeks. Because first introductory was just simple. It was basically idea of the function, syntax, and all those things you would be using in this course. Yeah. And then using this function, how would you develop an algorithm? So you can also write a FFT, fast Fourier transform, and everything you can code it up simply. Okay. See you next time. Bye.
Thank you, sir.
Yeah.
Thank you, sir.
Bye. Yeah.